Hello, and welcome to the Juniper JNCIA JUNOS exam video series. My name is Chris Frisch. This is the introduction to JUNOS OS, the first in this video series. I just want to start by taking a moment to tell you a little bit about this video series and let you know what it's going to cover and what you should be able to take away once you complete this series. So this series is all about the Juniper JNCIA JUNOS exam, or the JN0-101 exam. In this series, we will cover a lot of information in a relatively short period of time, so please take the time to watch a section again if you feel the need to do so. Now, not only is this series intended to help you pass the exam, but it will also give you the knowledge and help you build the skills necessary to work with Juniper equipment in the real world. To talk a little bit about the structure of this video series, these videos will be laid out in a structured way according to the Juniper exam objectives, which can be found on the Juniper website. Each major section will contain several videos regarding the objective topics for each section. Each major section will have a lab at the end. At the end of the section, I will go over a lab example to demonstrate the concepts discussed in that section, after which you will be given a lab of your own to do. Keep in mind that all the points discussed in these videos are relevant to the exam and your ability to work with Juniper equipment in the future. So pay close attention, take notes, and take breaks often. I would even suggest watching most of these videos more than once. So this video series has two primary goals: help you pass the exam and gain the ability to understand and work with real Juniper equipment. With that in mind, everything we cover here will be on the exam. So let's move on to discussing some of the fundamentals of the JUNOS OS architecture. We will discuss what JUNOS is and how it is different from other manufacturers. And let's face it, JUNOS is different. If you're coming to this video series from, for instance, a Cisco background, JUNOS may seem like a bit of a foreign language at first. But that's okay, because as you progress through this video series, the JUNOS platform is going to start making a lot more sense very quickly. So what is the JUNOS OS architecture? Well, if you ask the people over at Juniper, they like to say that the software is just cool. Juniper has put a tremendous amount of resources into building this software from the ground up to produce an operating system that is highly scalable and stable. The JUNOS software is built on the FreeBSD kernel and retains many of the FreeBSD features that make it a stable and reliable kernel. One of the reasons why Juniper refers to JUNOS as having a modular architecture is because the JUNOS services ride on top of the FreeBSD kernel and are completely independent of each other. Services can be added or removed based on the hardware or appliance specifications and needs. Each process runs in its own protected memory space. This ensures that one process cannot directly interfere with another process. Having these services completely independent of each other offers huge advantages. For example, system services run separately and independently from security services, and clustering services are not dependent upon system services, and so on. Since these services are not built into the fabric of the OS itself, but ride independently on top of the kernel, if there is a failure in one service, it does not necessarily affect the others. Something else you may have noticed is if you have ventured into the command line of a JUNOS device is that there is a hierarchy of commands that you don't see in other devices. Because of the modular design of the system, Juniper has been able to create a CLI structure that is highly logical and intuitive to navigate. For example, all commands related to system services start with the command system and drill down from there. But we will go into more detail about navigating the CLI later on in this series. JUNOS OS is used with most of Juniper's product line, with the exception of a few appliances like the SA series devices, but those are outside of the scope of the JNCI JUNOS certification track, so we don't really need to worry about those right now. JUNOS runs devices from the branch to the core of the network, from routers to switches to firewalls. Because JUNOS is used across the board for most of Juniper's product line, You have a single software release track to keep track of and one architecture to learn. All Junos OS devices share the same base source code, so Junos is the foundation for learning any new Juniper device. So let's move on to talking a little bit about the control and forwarding plane. One of the first things we need to understand about Junos devices is how they process traffic. So let's discuss the functions and operations of the control and forwarding plane on a Junos device. Control is key when we are dealing with these devices that process and pass traffic through our networks. When a Junos device receives a packet or frame, the first thing it needs to do is figure out where that information is going. The control plane is where the device determines what to do with the data coming in. Then it tells the forwarding plane, also known as the data plane, what to do with the data, and the forwarding plane carries out the orders. You could think of it like the control plane is the brains of the operation and the forwarding plane is the muscle. When packets or frames come in on an interface, the control plane processes it through the RE, or the routing engine, checking it against the routing table and then the forwarding table, and comes to a determination on where the packet or frame needs to go based on the configuration of the device. The control plane then passes the instructions to the forwarding plane, and the instructions are carried out. The packet will either be dropped or passed on to the outgoing interface. The routing engine, in essence, controls and monitors the chassis. It therefore manages the PFE, or packet forwarding engine. Like I said before, the routing engine is in the control plane, and it's the brains of the operation. So it tells the PFE, or the packet forwarding engine, what to do, as the PFE resides in the forwarding plane. With Junos devices, the control and forwarding plane are completely separate and independent of each other. This is so that devices can better handle unanticipated loads and actually pass traffic faster as both planes are running concurrently. What this means to you as an engineer is if for some reason your Junos device starts getting bogged down with large amounts of traffic for one reason or another, or a configuration is implemented that is having unintended consequences, you should always be able to reach the device and make configuration changes. The control plane should never be affected by excessive loads and traffic to the point that you can no longer manage the device, as can happen with some other manufacturers. Another example would be if you were troubleshooting a device that is in production, like a router or a switch. A tool that could be very handy in troubleshooting issues is turning on debugging. Some other manufacturers will advise not to turn on debugging on a production device because it can draw a fair amount of processing power. With Junos, because of the separation of the control and forwarding planes, and thereby the separation of the routing engine and the packet forwarding engine, you can turn on debugging, or trace options as it's called in the Junos world, and see the debug information in real time while maintaining your packet forwarding rates. This is pretty much what the separation is all about. The control plane is home to and maintains the routing table, bridging table, and the primary forwarding table. Keep in mind that the forwarding table only contains active routes and is primarily used to process transit packets. Also notice that the routing table exists in the control plane and not the forwarding plane. Something else to notice is that the forwarding table exists in both the control and forwarding planes. The forwarding table in the control plane is referred to as the primary forwarding table. The forwarding table in the forwarding plane is basically a copy of the one in the control plane. The forwarding plane is ASIC based, as it offers better performance for extremely fast execution of packet forwarding. Just keep in mind that the forwarding plane does all the legwork in moving the packets and frames around. So it pretty much does what the control plane tells it to do. So let's recap what we've covered so far. We talked a little bit about this course and about what you should get out of it. We also talked about the structure of the course and labs. Remember to go ahead and watch a section again if you feel the need to, because everything we are discussing here is important and will be relevant to the exam as well as your ability to work with Junos equipment. We also dug into the functions of the control and forwarding planes, which again is going to be important. There are not a whole lot of questions on the exam about the control and forwarding plane and the JUNOS operating system, but there are a few. Juniper wants to make sure that you understand what it is and how it works. The good news is, though, you now know everything that you need to know to answer those questions with confidence. So that's it. Now it's time for the lab. You should go ahead and move to the lab video. Thanks for watching.